Brainstorm what ifs. Have the team think about the design and understand how the generator works so that it can be modified to build some of these other possibilities. It's an opportunity to learn, to work on it with your team, and most important, have fun. Keep building. Variations on this generator are pretty amazing. Again, we didn't think about this when we built the generator. That wasn't the intention. The intention was to teach about generators and to be able to build a generator that was capable of entering the Kidwind competition in the home-built generator class. But it has other possibilities. Here's a generator right here. Okay, and it's a 4-bay generator. And look, you can actually add another stator and rotor, and now you actually have 2 generators on the same chassis. Okay, another variation is the design we thought about, or was if you can actually print just the base, and you can make multiple generators on the same frame. Okay, you can put gearing in here, plenty of room to add gears on a lower shaft. Yeah. Another variation, 2 generators with gearing. A design idea we had originally, which we never finished working on, was the 3-phase generator. And with this particular stator, we made the stator for 3, but you could use the blank stators and add 6 coils. And it has the external set of diodes here to change it to DC. But again, here's a 4-bay. If it's a 4-bay, you can add gearing to it. You could add 2 3-phase generators. Again, there's so many variations in what is so simple to build here. Can be very, very high tech. In the college competition at Kidwind, I noticed that they were building these axial flux generators, and here's the version of this generator modified for axial flux with actually another rotor on it, which doesn't need to be here. But so you've got, you noticed it here, but there's no magnets on it, but there would be a set of magnets here, coils in the middle. That would be your axial flux generator. Very difficult to put together, but I have built one, and it does go on this frame. Again, you could just go with the 2 standard generators, 2 3-phase generators with, right? And in this case, kind of interesting, you notice that the bearings are put on this end, so most likely you'd have your blades would be out here. Okay. The original idea with the 4-bay generator was to just provide a place to put gearing, because we know that it's important to match the output of the blades to the generator. Kidwind blades are usually large and work at low speed, They have a lot of torque, but very low RPMs. And this takes care of the RPM problem by converting the torque to RPMs and giving us a simple way to change out the gearing to match the actual output of the blades. We're just going to light things up for Kidwind, and hopefully one of these designs will work for your team. The basic generator was still a fine design, and it's still a very buildable, competitive machine. So if you want to go the extra mile and try some of these other designs, what's nice about this design or these parts is that it's very expandable. You could always start with this one and then decide, oh, we've got time, let's just for the heck of it try one of these. Okay, all right, let's try 2 generators. Okay, the possibilities are endless, and it's all because Kidwind decided to think about moving competition in a direction that would lead to more engineering and provide an opportunity for those advanced teams to easily build a generator and to explore the possibilities. This year I hear that the wind speeds, there will be another wind tunnel with higher wind speeds, and this generator is well suited to be modified to handle different inputs, especially, you know, the geared machine can be run off either side. So if it's high speed and if it's the high speed wind tunnel, if you can adjust your blades properly, you can always use use this side, put your blade. Kidwind competition provides a lot of different challenges, and I know that they're thinking about testing at different wind speeds. This particular machine, the 4-bay with gearing, is very adaptable, easy to switch out gears for competition, easy to decide the range of RPMs you need and to use either one shaft or the other shaft. You can input on either side. Multiple rotors might just answer the question, can I get away without gearing? And this is an unproven design. All the parts are here, they should work. The axial flux generator is a generator that the college competition uses. Again, it's a much higher output, a little more difficult to build, but this project, this combination of parts makes that buildable very easily if you're careful and you think about the design constraints that you have to employ in making the unit. The variations in bearing supports is obvious here. The variations in gearing, the variations in rotor, stator designs, very flexible, very flexible. The idea of going with a 3-phase generator, very possible, very possible. And hopefully this design will be what your team needs to get the next step in Kidwind competition. Most teams are constrained by time to build, time to test, time to design, and what we've done here is we've taken a big piece of the design and made it simple, in that other than having to actually physically make parts to test, here you can print some parts and then start to work with various coil designs by changing out, testing the static test. And again, gone through all the tests and the building process in other videos, but making just one coil and testing it, and then building the other coils is a quick and easy starting point. Building a rotor, okay? Again, not a very complex task when you have the beginnings of the generator already done for you. Okay, so bearings already done, base already done. Okay, so now once you get past this point, you start testing. You come up with data, you decide, oh, let's try a different rotor, let's try another stator. Maybe your team is well beyond that. You may just transition right to, oh, let's try 2 generators. Oh, that's a good idea. Simple to do. Make another rotor, add another stator. I'm now testing 2 generators together. Okay. Oh, that's not the way we want to go. Maybe we should just add some gears. Okay, let's try that. Same base, switch it out, make some gears. Plenty of gears to make. You can try different combinations of gears. Okay. Oh, maybe that doesn't work for you. We got our own really complex design we want to work on, and maybe using the separate dovetail pieces and building a couple of generators with gearing all tied together. This ought to be awesome. Let's try it. Okay, again, easy to build. You can put this together in a very short period of time once you've printed enough parts. Last thing is, maybe you just decided 3-phase generator. We read all about it. Looks like the HUD setup. Let's build a 3-phase generator. And maybe we want, and then we're open enough here. If we use a 4-bay, we can decide, oh, you know what? We need to add gears to this. Okay, we're done with our generator. Let's add some gears. We don't need gears. Okay, we can run without gears. You can run with gears. The design is very, very flexible, and it gets you into the advanced generator, home-built category quickly. It teaches you a lot about generators, and it's fun to do. I've had a ball doing this, and I hope you have